Right, I realise it's late in the afternoon and you're probably all a little bit like, oh, there's another talk going on, but it's going to be good. It's going to be a little bit short in the grand scheme of things because software craftsmanship is kind of a massive thing. So we're spending about 10 weeks with about 3 hours a week for every engineer in the building, coaching them through all this stuff that I'm kind of going to rush past you in the next 25 minutes or so. So just to get a feel for this, who has heard of software craftsmanship? Stick your hands up. Good, everyone's kind of, everyone, half, 3/4 of the people. So if I'm not going to ask you, but if I had to ask you to stand up and tell me what it actually is, who could do that? It's less people, right? Okay, good. I was kind of hoping for that. So software craftsmanship really is about software engineers, QA engineers, UI engineers, mobile engineers, whoever they might be, writing software in a way that makes it very easy to change and to do only the things that it's supposed to do. Software engineers are craftsmen, right? It's not data entry. They don't sit there and just kind of smash stuff in. It's a creative process. You're solving problems in code. And as with any kind of craftsman, craftswoman, please assume that I'm talking about craftswomen as well as craftsmen, that you hone your skills over time. You try new things, and if you think they're good, you incorporate them into the way you do things. So, what is software craftsmanship? Well, I'd be lying to you if I said that there was actually a definitive answer to this, because there isn't. But for me, it comes down to three main things. It's a collection of techniques and approaches. It's a mindset, a way of thinking, and it's also an understanding of the tools that make this stuff quicker and easier and simpler to do. So I suppose if you think about building a shed, you're going to see this in woodwork-related stuff going on here. So if you decide that you're going to build a shed, you can kind of take two approaches, I guess. Either you can plan the whole thing out in advance. This is not a waterfall versus agile thing. You can plan the whole thing out in advance. You plan every single joint and you know exactly how many screws you want and what you're going to do, but you don't really get any benefit from that until you actually start building the shed. And it's hard to react to change in that shed because you might come across some pipe work in the ground and then you have to go back to the drawing board. On the other hand, you could do what most software engineers do, is that you just start writing some code and you go, okay, right, yes, brilliant. Or you start building a shed and you go, right, I need a bit of wood there. And you realize you don't have a tool, so you go and buy a tool, and then you find a new tool that looks kind of funky, so you're going to use that instead. And then maybe you're going to stick this bit of wood to this bit of wood in this way, but when you come to do it over here, you kind of think, actually, no, maybe I'll do this here. And what you end up with is a thing that gives you benefit straight away, but it's kind of all hooked together in crazy ways, and when you need to repair it, you kind of don't know what's what, and you kind of have to look at it and go, how the hell did I fix that to that? So there's kind of a third way. So let's say you have a good understanding of the kind of joints that you could use to fix two bits of wood together. And maybe there are three that kind of common joints that you would use. And you know that you need you need a hammer and a screwdriver and a drill, and you need screws probably about this length, and you know roughly that if you're going to do something this big, you're probably going to need about that much. What that means is that you can do things in a consistent way, but still react to change as you go along. When you find some pipe work in the ground that you can't dig up, you go, okay, well, that's fine, because I can actually just do one of these joints here, one there, and I've actually got a little corner bit. And when you come to repair it later on, or someone else comes to sell your house, and someone looks at your amazing shed and goes, wow, but I want different boards on the front of it, they can look at it and go, I see how that works. I can basically just take this bit off here and put these bits on. And that's the kind of thing we're trying to get to with code. So what's well-crafted software then? Well, again, there's no real definitive answer, right? But for me, well-crafted software comes down to three key areas. It's software which is adheres to good engineering principles. And by those, I mean things like solid, KISS, dry, Yagni, tell, don't ask. So these are things that you may or may not have heard of, but they're generally well accepted principles for writing software, which means that it's easy to understand and it's easy to change, which is great. Clean, simple, elegant code. You should be able to read it like prose. It shouldn't be like trying to understand this mathematical equation or some cryptic message. It should read like English. Unless you're writing in French, it should read like French. But you get the idea, right? It should read like prose. And finally, it should take a test-first approach, because there are two benefits. One is that as you change that software, change that code base, you know whether you've broken it or not. Pretty simple. It also means that you're only doing what you need to do. You tend not to start building the world. In the .NET world, it's like, you know, starting off with iRepository T. So I'm going to need to be able to store everything at all times, and I want to do it through this one interface. It's like, no, you really, really don't. So I don't know if anyone remembers this film, by the way. Does anyone remember this film, Weird Science? No. Oh, one nod. Come on. Two. Ah, that's a shame. This is a classic. These guys, so this is Wyatt and this is Gary, and they basically they make a woman from their computer, and Gary's going, oh, we need to have this and this and this, and Wyatt's going, all right, I'll do that and I'll do that, and he makes it up as he goes along. He's got no tests to check whether it works or not. They create a woman, which is awesome, and then these two guys turn up and they try and do it again, and they go through everything again. This time they make a missile in Wyatt's house, which goes through all the floors. So they are probably the best, worst software engineers in history. So let's talk a little bit about clean, simple, elegant code. Clean Code is a very famous book by Uncle Bob, Robert C. Martin. You don't have to agree with it all, but I would certainly recommend you read it, at least the first half of it, because it gives you a certain mindset about stuff. Like, you should name things in a way that tells you what they are. Fairly simple, right? If you're naming your variables A, B, and C, probably people aren't going to be able to read your code. It talks about method names and lies. So if you call your method get, but actually it goes and deletes something and then adds it and then returns it, that's a lie, right? Because get doesn't sound like it does that. And it should be elegant. It should be a pleasure to read. You know, if you see good code and you look at it and you go, wow, that's really nice, really simple, I like that, then you've nailed it. So I'm going to do a little example, not a big example, but just to illustrate that point. Assuming that somewhere I've got one of those, and I can put it up there. There you go, bad name example. What does this do? This is called add, and it takes an integer A and an integer B. If I read that, I would think, oh, it adds those two numbers together and returns it. You'd think that, wouldn't you? But no. Otherwise, it'd be a bit of a rubbish example. What it actually does is a whole load of other stuff. And I don't know, I'm going to give you like 30 seconds to have a look at that. I'm not even going to give you that long because I'm bored of the silence. But basically, there's a whole load of stuff going on. And actually, I'm just looking at this, scratching my head going, well, I thought I just added those two things together. But hang on a minute. It's creating stuff, and it's updating stuff, it's handling exceptions, it's returning some kind of -1, 0. What does that mean? Is that good? Is that bad? No idea. So that is a perfect example of really bad naming. But even if you couldn't change the name, right? Let's say you had to refactor this. You came across this, you thought, that's really bad, I need to change that. You can't change the name of that, it might be other things calling it. But there's stuff you can do. So if I were, for example, to change this, and this again comes down to the tooling, right? So if I refactor that, I don't have to type any code into here when I'm refactoring. The tools should be able to do it for me. So what if I called that customer ID? And there you go, all right, that's interesting. So it's not adding that to that. And then what if I were to call that something like loyalty points to add to customer? Oh, except that I've clearly not typed it. Keyboard fail. Keyboard fail doesn't count as bad software craftsmanship, just for the record. Loyalty points to add to customer. Then suddenly you read this and you look at, in fact, if I just take that away, let me just minimize that again. Collapse that, right? So suddenly you read this, you go add customer ID, loyalty points to add to customer. And you think, okay, well, probably what this does is add some loyalty points to this customer. And just by changing the names, I've described the code. Now, it might be that previously I had some comments above here to say this add method adds loyalty points, and A is this and B is this, but I don't need it because it reads like English. I won't go through that whole example because we probably don't have the time. So, let's go back to here. Damn. Let me try that again. Yay! So, good engineering principles. It's a famous picture. Good engineering principles. I'm not going to go through these in loads of detail, but solid is really important. So for those who aren't familiar with solid, it's 5 principles which basically break up your code in a sensible way so that you can change things without having to change other things as well, and you can inject things into your code rather than hard code them and that kind of thing. So if you don't know the solid principles, go and look them up. They are invaluable. Things like dry, don't repeat yourself. It's fairly obvious, right? If you're writing it twice, you've got to change it twice. So if you're writing it 3 times, then your effort is going up and up and up. Why don't you just write it once and maybe parameterize it somehow? KISS, keep it simple, stupid, applies to everything in life, but definitely to writing code as well. YAGNI, you ain't going to need it. Don't think that you're going to, oh, I know one day we have this vision that it's going to do all this. But actually, all it needs to do right now is return a 0. And so instead of creating a huge number generator and storage class, you just return 0. Simple. Add it in later when you need it. And tell, don't ask, which is all about, you don't go into your bank and say, could you just give me a list of all my transactions and I'll add them up and get my balance. You kind of go, what's my balance? And they go, what's this? Win. So, simple stuff, but it's gone all out of kilter now. Technical fail. There we go. Right. So, do you know what I'm going to do? I'm going to do that. Stop listening to me entirely now. Right. Hold, please, callers. Your call is very important to us. Test first approaches. There we go. Cool. So test first approaches, largely when you're writing code, comes down to test-driven development, TDD. There's a whole debate, I'm sure you're aware, about TDD is dead, moving to onion architecture. Great, all healthy stuff. For me, I really enjoy TDD. I really enjoy the fact that I generally drive out my code automatically rather than actually sitting there writing code myself. I find it pleasurable. Some people don't. That's fine. But let's just talk about quickly recap the 3 rules of test-driven development. You can't write any production code unless you're passing a failing test. You write a failing test to prove your code base doesn't have it, so then you add it in. And you're not allowed to write any more of a unit test than is sufficient to fail. So you don't start building out these massive test journeys. You're just driving out one thing. And you're not allowed to write any more production code and is sufficient to pass that one failing unit test. Pretty simple stuff. This will become a little bit clearer in a bit when we go through some of the other techniques. So, techniques, mindset, and tools, which I talked about at the beginning. There are some things here, and these are, I suppose this really is the crux of this talk. These are the kind of things that if you bear them in mind, if you go off and look them up and print them out and stick them on your desk or whatever, if you bear these in mind as you go, it really does change the way you write software. So simple design is kind of what we're trying to end up with. So there are 4 rules of simple design, 4 elements of simple design, as outlined by Kent Beck. Again, I'm not teaching anything new here. I haven't got any original material. This is all stuff that's out there that you can go and find and change the world through software right now. Not right now. Wait till I've finished. So, the 4 elements. It passes its tests. It's pretty simple, right? If it passes its tests, then what that probably means is that you've documented the intent, the design of your code, because your test should explain what it's supposed to do. It also means that when you refactor it, you know if you've broken stuff. Minimises duplication. So so this comes back to dry, don't repeat yourself. As we find duplication, we tend to break out classes rather than doing things in multiple places. Our code base tends to become more concise. There might be more classes, but there'll be less lines of code, which makes it more obvious. Maximizes clarity, so this comes back to naming things, separating them out. It should be really obvious what your code does when you look at it. You shouldn't have to go and dig through stuff and hope for comments. And has fewer elements, so by using appropriate techniques, we can actually reduce the amount of stuff that we've got to look at, and that's got to be a good thing, right? This one's really good. So this is a set of priorities. And this comes back to the driving out just what you need to do something. This is the return 0 instead of creating a number generator, factory manager, or whatever it is. So this is, hopefully you're going to be able to see this because they're quite small. This was put together again by Uncle Bob, Robert C. Martin. And what it says is, to solve a problem, you make the smallest transformation possible. So transformation is when you're changing the behavior of code, as opposed to refactoring, where you're changing the code but not the behavior. So our return 0 is an obvious example. Let's say we write a unit test that says, return a number, whatever it might be. Or let's say we write a thing that returns us an object. A unit test fails because that method doesn't exist yet. The simplest thing we can do is go from no code at all to return null. And that will pass our unit test, because we've got an object. It might be null, but it's a thing, right? You go from there to a constant. So let's say, back to our return 0. You could actually just return 0. That's a constant. It's an inline literal, but it will pass the test. And so on and so on. You go from constants to a bit more constants to a scalar, a variable, statement to a number of statements, something unconditional to an if, so you start to split the logic path. You go from a single value to an array of values, an array to a container, so rather than just a fixed list, you actually can add and remove elements, for example. Statement to recursion, so this is the bit where most people who get into software engineering will either have the minds blown or go, oh, yeah, I remember doing that at university. And then have the minds blown because they'd forgotten how good it was. Recursion is really, 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 really powerful and something we don't use enough. If to a while, so instead of just doing one thing, we continually check it. Expression to function, variable to assignment, if to a case, for example. So you can actually follow these. There are katas that you can do. So you can do the Roman numerals kata. If you're not familiar with that, just look it up. You can look up all the stuff I'm talking about here, and it will probably be like the top result in your search engine of choice. You can actually go through every single step of this during that kata, and it really brings out what they mean. It's definitely worth doing. transformation priority premise. This is the one that really changed my world. I love this stuff. So object calisthenics is actually a ThoughtWorks thing. So it was a guy called Jeff Bay, and it's published in the ThoughtWorks anthology. And it's basically 9 things you're not allowed to do. And it's an exercise. It's not necessarily. It's not something that you should sit and write production code following all of these things. But you should use it as an exercise because it properly changes the way you see software design, especially emergent design, as you're writing stuff. You're only allowed 1 level of indentation, so you can't nest stuff. Fine. You're not allowed to use the else keyword. You start going, oh, okay, that's a bit weird. Wrap primitives and strings. So basically what that means is you're not allowed to pass around value types in .NET. You're not allowed to pass around primitives. You can't pass an int, for example. You have to wrap it in an object. Why? Because an object has domain properties or domain value, whereas an int doesn't, for example. We saw that when we were returning 0. Return 0. Great. No. Yeah? No, I don't know. Return failure code, success code. Cool, we know what that means. It has some domain value. First class collections, 1 dot per line, blah, 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 blah. Good, 9 things. So this is the one that killed me. No properties. And I started doing this with the Game of Life, Conway's Game of Life kata. And the first thing you do is, okay, I'm going to need to keep some state, that's fine, I'll expose it through a property, and then you go, I can't have properties. And the guy I was pairing with, who's a lead software engineer, very, very capable guy, we sat there, we scratched our heads for about half an hour, thinking about all these clever ways we could do it, until in the end we came upon something just really simple, is that actually we could just take a polymorphic approach and say, we've got 2 different types of this thing, and we don't need state at all. And we looked at it, and we did the whole thing in about 3 lines of code, something stupid like that. We looked at it, and said, this is amazing, absolutely amazing, but we never would have done it. Why? Because the easy route was just go, yeah, let's have some properties and stuff. So this really changes the way you think about design whilst you're writing software, and I thoroughly encourage you to go and have a closer look at that stuff. Code smells. So last of the slideware, largely. Code smells are really important when you are working not only with your own code, but other people's as well. Right? So there are about 20 odd of them, and they're things that suggest something's wrong. And those things have some pretty well-defined ways of fixing them. And you can group those 20 odd things, it depends which source you look at, 23, 24 things, into 5 main areas. So bloaters, this is usually the case, you see this a lot. This is the case of organic growth in a code base where stuff gets bigger and people add stuff. The obvious ones here are long methods. If you've got a long method, then probably it's doing too much. It's breaching the single responsibility principle. You should probably break it up. Simple stuff. Same with if you've got lots and lots of parameters to a method. Probably doing too many things. Object orientation abuses. This could be something as simple as a switch statement. So it could be that actually you should be taking a polymorphic approach, and actually you're kind of cheating and using some state in a switch statement, that kind of thing. The other one is the beautifully entitled refused bequest. So refused bequest is one of those things that you inherit from something even though you don't need all of its stuff. So you might need to create a chair class, and you think, well, chair's got 4 legs, so cat, I'll go and inherit from cat. But then what do you do in the meow method? You go, oh no, throw a not implemented exception there because I don't really need that. You kind of screwed up the inheritance hierarchy. Change preventers. So change preventers are things which basically stop you from making simple change. Don't stop you changing stuff, but they make it difficult to change stuff. And one example of that is sometimes people go too far on the other side of single responsibility, and they break things up across loads of different classes, and that's called shotgun surgery. And shotgun surgery is where you kind of go, right, I'm going to take that, and it just goes everywhere. So when you change one thing, you need to change everything else as well. So we want to avoid that, because what we want to be able to do is change simply and with confidence. Dispensables, stuff that just shouldn't be there, really. Comments is one. Comments are very much like bad jokes, really. You shouldn't have to explain a joke. If you do, it's a bad joke. The same as goes for your code, right? If you have to explain your code, maybe you need to write it a bit more cleanly. Couplers, so there are a few of these. I suppose the most obvious one that you might see is message chains. So you might have customer dot address dot country dot is in Europe or out of Europe. Basically what that means is that everything that uses that is coupled all the way up to customer. So if you're going to change anything, you have to change everything in the hierarchy. And the last thing really is just to talk about pair programming, just to say it's a really, really good way of learning all of this stuff, because if you sit down with someone and there are a couple of techniques you can use. Popcorn pairing is a really good one. One of you writes a test, the other one writes the code that makes it go green. That person writes a test, the other person writes the code that makes it go green. It's a really good way of sharing ideas and contributing to a code base. One of you is the driver, operating the keyboard and mouse. The other's a navigator, advising, backseat driving, spotting stuff. And it's just a really good way of developing code. You don't have to do it with production codes. Maybe you don't want to do that. Maybe you just do it as an exercise with some katas. I find it really good fun. And I didn't when I first started pairing. I hated it. It's like someone's watching over me. Oh, I'm going to get something wrong. But not like that at all. The other thing you can do is you can set a timer, like a chess clock. So you get a certain amount of time doing stuff, and then you swap over, that kind of stuff. And kata, I keep mentioning katas. There are loads of them. Go and search for them. You can do them in any language. And the simple ones like FizzBuzz is a really, really obvious one. The Mars Rover one is really quite interesting. Game of Life. There are tons. I won't enumerate them all. Go search. There are websites of them all over it. So, that's me. Thank you very much. Any questions? Oh, no. Does that mean that I've covered everything perfectly? Love you guys. Ah!
Can't get away without any. So, awesome stuff. But I assume, like most companies, you use vendors as well. What are you doing about trying to bring your vendors on board to make sure that they're writing good quality code?
Okay, so firstly, we have full-time software craftsmanship coaches who work with all of our engineers across the board, going through all of this stuff over the course of 10 weeks, blah, blah, blah. Our vendors, we provide a set of expectations, which basically revolves around writing clean, simple, elegant code that's driven by a test-first approach and adheres to good engineering principles. And every commit they make has to be reviewed by one of our principal software engineers or lead software engineer. And if it's wrong, we'll ask them to do it again. So we kind of educate. Obviously, we don't want to do that every single time. We try to educate so that it gets better over time. Good.
Thank you very much.
Thank you.